So here we have a show that question. We're looking for an identity here. Generally I'd start with the left hand side or the more complicated side, and we're trying to simplify it. I can see that on the right hand side I've just got one term. So on the left hand side, my first thought here would be to combine it into a single fraction. I'm going to do that. I would want common denominators, so I would multiply this first fraction by sin x, and then we're multiplying that second fraction by 1 minus cos x. Look at the numerator. So in this first fraction I've got sine squared x on the top, and in this second fraction I've got 1 minus cos x all squared. So I can now write, combine them as a single fraction, sine squared x plus, expanding out that bracket, 1 minus 2 cos x plus cos squared x, and that is all over sine x times 1 minus cos x. Next thing I could see to simplify on the top is I've got sine squared x plus cos squared x equals 1. It's always worth writing the identities that you're using out separately, just so your examiner can see those as well. So here we've got 1 plus 1, so I've got 2 minus 2 cos x over sine x times 1 minus cos x. I can see that I can factorise the 2 out of the top, leaving me with 1 minus cos x. That's quite convenient because that's what I've got in the denominator. I can therefore cancel those out, and that leaves me with 2 over sine x, and 1 over sine is cosec, so that leaves me with 2 cosec x as requested. K is a constant to be found, so it is again worth writing k equals 2 and checking it satisfies. Yep, good. So 2 cosec x, job done, 4 marks. So moving on. Hence explain why this equation has no real solutions. First thing to do, check that this left hand side is exactly what was written in part A. Sometimes it is changed slightly, so you need to amend what was in part A. So from there we can say, well, this would be 2 cosec x, that's what we've just proven, is 1.6. So here I've got 2 over sine x is 1.6. If I multiply up, let's say 2 over 1.6 is sine x. That's that 20 over 16, 10 over 8, 5 over 4. So 1.25 equals sine x. And that's from there we can see no real solutions, because the range of sine x is from -1 to 1. So there can't be a value of x that gives a sine of 1.25. Mark schemes on the next slides. That's just identical to what I've just done, and similar here. I mean, I just went into sine there. They've just gone for cosec being undefined in that region, equally valid. So either method is fine.